Abhiyanta Siksha is launched with a motto to impart an experiential understanding of technical education. The course outcomes are: equips junior engineers to solve real-time industry problems, prepares graduates for competitive exams, supports engineering students in their graduation studies, benefits diploma and high school students in engineering sciences. Problems are explained, solved, and supplemented with hands-on practice for students. Welcome to the online course Abhiyanta Siksha. The topic that we are covering in this course is engineering mechanics with subtopic friction. Session 2: Applications to friction. Let us study about wedges, connected bodies, ladder, belt friction, and rolling wheels. Wedges. A wedge is one of the simplest and most useful machines. A wedge is used to produce small adjustments in the position of a body or to apply large forces. Wedges largely depend on friction to function. In the figure, block A supports a load W and is to be raised by forcing the wedge B under this. The contact reactions between the blocks at this common surface are not only equal and oppositely directed on the free body diagram of each block, they also act so that their tangential or frictional components along the normal contact surface oppose the impending motion of each block relative to the other. So this is the wedge, and this is moved with an external force P so as to raise the block on which some weight W is placed. So for the wedge to slide out of its space, slippage must occur at both the surfaces simultaneously, otherwise the wedge is self-locking. So wedge is in contact with the ground as well as with the block A. Okay, now let us understand the concept of wedge with more clarity. Okay, so as I said, wedges are machine components that are used to raise the or lift the heavy objects. Now look at this figure. This trapezoidal geometry is a wedge, and this is a block placed on the wedge, and suppose there is some W, another weight. It can be a machine or it can be something very heavy heavy objects placed on the block, which has some tons of weight is kept on the block. Now the objective is to move this weight in upward direction. That means to raise the weight. For this to move up, that means the block has to move up. For this to happen, we apply a force P on the wedge such that the wedge moves in rightward direction. Because of this inclination, the block starts raising on the wedge. Thereby, the machine or the heavy object that is placed on the block also raises along with the block. Now let us understand the forces that are involved in this entire mechanism. Okay, now I shall solve this problem in two methods. Method 1 is resolution of forces. Method 2 is vector method. Okay, so first method 1, that is resolution of forces. Okay, now to know this, we should know, first of all, understand what are the forces that are acting on the body. Now first let us take block A. The block A in this particular system is in contact with the vertical wall or vertical surface. 1 is with the vertical surface, 2 is with the wedge. Now we can take now one more. Wedges are weightless components. They are weightless component. That means negligible weight. Weightless means negligible weight. So when you are assuming this one here, we know the motion of the block, it is going upwards. So we know the frictional force that is acting on this surface, it will be downward direction. Coming to the frictional forces on this contact surface depends upon the motion of the wedge. As the wedge is moving towards right, the frictional force on the wedge at the top and at the bottom will be in leftward direction. So, for equilibrium condition, the frictional force on the block at the contact surface will be opposite to the wedge frictional forces. That means they can be in this direction. And the normal reactions are also equivalent opposite to each other. Equivalent opposite to each other. Okay. Now, knowing this, let me first go for the block A. The block A is like this. The weight component acting here, W. There is no contact here or no force here, so this edge is free. This edge is in contact with the vertical surface, so let me call this as N1 normal. Since the motion is in upward direction, the frictional force here would be mu N1. Agreed? Right. Now, the next thing is this force. In this force, draw a normal reaction which is perpendicular to this surface. I call it as N2. Now, you should know whether the frictional force is in right direction, left direction or right direction, isn't it? As I said, since based on the wedge motion, you have to represent the frictional force. Since the wedge is moving this way, the frictional forces on the wedge caused because of the block and the ground surface will be leftward. So, the frictional force on the block now would be opposite to this force, that is towards right. So, the frictional forces are mu and 2. If you know, this is block A. Agreed. Now, you should resolve them to one particular plane. Let me say I shall resolve this into this direction and in this direction. So, this becomes theta and this becomes theta. So, let me put everything in y and x plane, xy plane. So, this is x plane, this is y plane, xy plane. So, I have w here, downward direction, mu n1 also in downward direction, n1 towards right. Okay. Now, resolve these forces. Once you resolve these forces, they can be mu n2 cos theta and mu n2 sin theta. Similarly, if I resolve this can be n2 cos theta and this is n2 sin theta. So, negative n2 sin theta and mu n2 cos theta sin theta, mu n2 cos theta. Downward direction is mu n2 sin theta, then upward direction here is n2 cos theta, right. Now, just apply the equilibrium forces. Sigma fx equal to 0 plus n2 sin theta minus n1 plus mu n2 cos theta equal to 0, equation number 1. Then sigma fy equal to 0 is plus n2 cos theta minus n1 mu n1 minus w minus mu n2 sin theta equal to 0. So, these are the two equations. From here, sometimes the mu value here can be different from here. That means, as I already mentioned, the coefficient of friction depends upon the materials that are in contact with each other. This can be a steel block and this can be a concrete wall. This can be a wooden wedge and steel block. So, the coefficient of friction here can be different, coefficient of friction here can be different, and even coefficient of friction can be different. Now, in this case we are assuming that the mu value is same everywhere. So, I am putting it, otherwise you need to be indicating the different coefficient of friction values also in the equations. Okay. So, from here you need to calculate what is more important is n2. N2 you need to calculate, okay, because that n2 again we are going to use here at the wedge friction values. Now, let me do for wedge. The wedge problem goes this way, forces on the wedge, okay, this is theta. This is the force P. As this is the force P and the motion is in this direction, the frictional force mu n2 is equal and opposite in direction. Okay, mu n2 here is in right direction on the block, mu n2 on the wedge is opposite to this, okay, upward direction. Then comes your n2 which is 90 degrees here, and there is one more normal n3 and mu n3. So, these are the forces that are acting on the wedge. These are due to the ground surface onto the wedge, Now, if you resolve these forces again, if this is theta, this is again theta, so this becomes n2 cos theta, this becomes n2 sin theta, and this becomes mu n2 cos theta, and this becomes mu n2 sin theta. So, put them again in x axis and y axis, all the forces. This is x, y forces. Upwards is n3. This is mu n3. Again this is P. Then this is mu n2 cos theta. Upward is mu n2 sin theta. But downward direction is n2 cos theta. And again this left n2 sin theta. So, I have placed all the forces on xy plane. So, now calculate again sigma fx equal to 0. Sigma fx equal to 0 is minus mu n3 minus mu n2 cos theta minus n2 sin theta
plus P equal to 0. Then again sigma Fy equal to 0 equation. I call this equation number 3. Then sigma Fy equal to 0. Now n3 plus mu n2 sin theta minus n2 cos theta equal to 0. This is equation number 4. So once you get n2, substitute to the n2 here and then derive the value of P. How much force is required? What does the P tell you? How much force is required to be applied on the wedge to raise the weight to a certain height? So this is useful for us to determine how much P is required. Now let us understand the same problem in a different method. That is the alternate solution. Now this is method 2, which is vector method, mostly based on the total reaction of frictional force. Okay, I call it as a vector method. Okay, now in this, let us first take the block. Now on the block, suppose this is the block. You have weight W, okay? Then you consider the reaction that is caused, resultant reaction, I call it as R2, which it is at an angle of phi. We have already discussed that when a body is placed on a surface and is pulled with a force, and the weight is acting downwards, you have normal reaction and frictional reaction, okay, frictional action. Now we can replace this F and N with R, which is at an angle of phi with N. So this R is called the resultant of frictional force and the normal reaction. So I am using now R2, which acting at an angle phi with the normal reaction, whereas your frictional force will be in this direction, normal reaction in this direction. The resultant of these two would be R2. So I am just replacing those two with R2, right? Then similarly, if you have this normal value here this way, and I can always say this also, then I can represent the resultant of this, call it as R1. R1 again is at an angle of phi with the normal reaction, and again theta with this vertical direction, with this vertical direction. Now let us, since we have three forces, vectors, let us represent those three in a vector diagram. Now let us represent the three forces in a vector method, which goes this way. W acting downward direction, your R1 in upward direction, and then R2 in this direction. So this is R1, this is R2, right? Now what is important is we need to represent the angles. The angle between W and R1 is theta plus phi. So I show this as theta plus phi. Then the angle between R2 and W, here this is 90 and this is phi. With the horizontal it is phi, right? So suppose W here, if you imagine W here, this is 90 and this is phi, 90 plus phi. So this is an unknown angle. Let me call it as alpha, where alpha you can calculate as the sum of the angles of a triangle 180 minus theta plus phi plus phi. Okay, so that you can obtain alpha from this equation. Now you need to, since you have three forces and a closed vector diagram, apply the sign rule. Apply sign rule to determine the unknown. Now, what do you mean by sign rule? Sign rule is the ratio of force vector to sine of opposite angle. That means, let me take first this vector R2. So, R2 divided by sine of the opposite angle, sine of the opposite angle, that is sine theta plus phi. Next, R1, that is equal to R1 divided by sine 90 plus phi. The opposite angle is 90 plus phi. That is equal to RW divided by sine alpha. So, the unknown alpha or R1 and R2 can be obtained by taking any two equations, relations, and solve the problems for unknown values. So, this is how you can solve the values of reactions from the vector method. This is for the block. Now, let us solve for wedge. Now, the wedge is this way. This is the force P. Then you have the resultant total reaction on this, let me call R2, which is making phi here, upward direction, right. Then you have, let me say, the same R1, okay, R1. So, this with the normal and with this, I call it as phi with this and theta with this, knowing that this is theta. Now, draw the vector diagram for this. For this, the vector diagram goes this way. This is P, this is R2, R2 with P. That means P is this way, right? R2 is with this phi, so this becomes 90 minus phi. Then comes R1. The angle between R1 and P, that means if you say this, the total is 90, 90 minus theta plus phi, 90 minus theta plus phi, and this is an unknown angle beta. Now, apply the sine rule to this problem. The sine rule goes like this: P divided by sine beta equal to R2 divided by sine of 90 minus theta plus phi, that is equal to R1 divided by sine of 90 minus phi. So, these are the ratios. Now, use any two ratios to get the unknowns. Thereby, you can solve the P value, that is the required applied force on the wedge to raise the body to a certain height. So, you can either follow a resolution of forces method or a vector method. Okay. This can be used only if you have 3 forces in the system. If you have more than 3 forces, then it is better to use resolution of forces.
Let's understand the concept of the wedge using a problem. The problem is, a block weighing 1000 Newton is to be raised against a surface inclined at 60 degree to the horizontal by means of 15-degree wedge. Find the horizontal force P, which will just start the block to move if the coefficient of friction between all the surfaces of contact be 0.2. Assume the wedge to be a negligible weight. Now let's understand the problem. The problem says that there is a block as shown in the figure which is of 1000 Newton and is inclined onto a surface which has an inclination of 60 degree to the horizontal, and it is being raised upwards by means of a wedge. This part is a wedge which is an angle of 15 degrees to the horizontal. Now the question is, find this horizontal force P required to be pushed in leftward direction so that the block 1000 Newton will just start moving up. And another information that is being given is the coefficient of friction between all the contact surfaces is 0.2. So what are the contact surfaces? One is the inclined surface and the block. The second one is the block and the wedge contact surface. And the third one is the wedge with the horizontal surface. So we have 3 contact surfaces and the coefficient of friction is 0.2 as to be assumed. Now, to solve this problem, we need to draw free body diagrams. Now in this case, we consider 2 free body diagrams separately. One is representation of forces on the block, and the second one is the representation of forces on the wedge. Now first let's go for the block. The block has a weight of 1000 Newton represented in downward direction perpendicular to the ground. Then this edge of the block is resting against the inclined surface 60 degrees. So the surface will be creating a reaction force on the block and represented as N1. And another force is the frictional force. Since the block is moving up, as the P here pushes the wedge in leftward direction, the block has to raise upward direction, right? So since the block is moving in upward direction, the friction here will be represented in downward direction. So your mu N1 is represented in downward direction. Now coming to the contact surface of the block and the wedge, this portion. In this portion, the wedge creates a reaction force onto the block that will termed as N2. So your N2, which is the reaction developed by the wedge onto the block, which is perpendicular to the contact surface, is represented in this direction, N2. Now, since the wedge is moving in leftward direction, the friction force on the wedge will be in upward direction, and the frictional force on the block will be quite opposite to that on the wedge. Therefore, the frictional force on the wedge will be in downward direction. So, mu N2 is shown in downward direction. I repeat this point. The wedge is moved in leftward direction by applied force P. Then the frictional forces that are acting on the edge will be in upward direction. Then the frictional force acting on the block will be equal in magnitude but opposite in direction at the contact surface of block. That means in downward direction. So, your mu N2 is represented in downward direction. So, now that you have all the forces and reactions acting on the block, you need to resolve these forces onto xy plane. So, let us consider the horizontal as x and the vertical as y axis. Now, coming back to the reaction N1 caused by the wall onto the block is at an angle of 30 degrees with the horizontal. Then you resolve this component. This becomes N1 cos 30 and this one becomes N1 sin 30. Okay. Then mu N1, which is again at an angle of 30 degrees to the horizontal, is resolved to mu N1 sin 30 and mu N1 cos 30. Then coming to the reaction by the wedge onto the block, N2 is at an angle of 15 degree to the vertical line. So, you resolve this N2 as N2 cos 15, N2 sin 15. Then mu N2 at an angle of 15 degrees to the horizontal will give you mu N2 cos 15 and mu N2 sin 15. Now, putting all these forces onto xy plane, you have x axis and y axis in xy plane, and apply the equilibrium equations for this. That is, sigma fx is equal to 0. So, sum of the forces on x axis is equal to 0. So, you take forces towards rightward direction and forces to the leftward direction. Similarly, sigma fy equal to 0. The sum of the forces on y axis are also equal to 0. So, the next free body diagram would be about the wedge. So, these are the equilibrium equations for the block. So, you can solve these equations and get some unknown values, that is N1, N2 reactions. Going to the wedge. So, this is the wedge. So, the wedge is a weightless component. So, you don't have to represent any weight on this. You have applied force P acting towards left direction. Now, since the applied force is in the left direction, the frictional forces will be acting towards right. So, this is the ground surface having N3 as the reaction developed by the ground onto the wedge and perpendicular to the surface. Your mu N3 is towards right because the wedge is moving towards left. So, similarly, N2 is now the reaction caused by the block onto the wedge N2, and this N2 is now again perpendicular to the wedge top surface. So, mu N2 now will be opposite to the direction of that developed on the block, which was downwards, right? Now, this is now in upward direction. Mu N2 is in upward direction. Now, again, resolve all the forces to x and y axis based upon the angle of inclinations. Now, N2 is 15 degrees with the vertical See, all this is simple trigonometry. You just have to place the angles. Mu n2 is 15 degrees with the horizontal. So when you resolve to mu n2 cos 15, mu n2 sin 15. Similarly here, n2 cos 15 and n2 sin 15. Put all these forces of reactions and external forces onto an xy plane this way and apply equilibrium conditions of sigma fx equal to 0 and sigma fy equal to 0. So let's go back to the equilibrium equations for the wedges of sigma fx equal to 0. So sum of the forces in x direction equal to 0 and sum of the forces in y direction also equal to 0. Solve these equations 1, 2 of block and 3, 4 of wedge, and then determine the value of P, which is 595 newtons. That means to raise a block of 1000 Newton in upward direction through wedge, you need a force of 595 newtons. So with less effort, you are doing more work. So wedges are also considered as a simple machine. Let's understand the application of a wedge as a wood splitter. The problem is, a wedge is used to split logs. If phi is the angle of friction between the wedge and the log, determine the maximum angle 2 alpha of the wedge so that it will remain embedded in the log. So it says that there is a wooden log and that wooden log has to be split into 2 parts using a wedge. Wedge is usually a tapered component with an included angle of 2 alpha and an applied force P acting vertically downwards on the wedge splits the wood into 2 parts. So the question here is, determine the maximum angle 2 alpha of the wedge so that it will remain embedded in the log. So this problem has to be solved in 2 stages. In the first stage, you determine the applied force P if the reaction is a known value. In the second stage, the wedge has to be driven and the force is removed to determine the angle alpha. So let us start with the first phase of the problem. In the first phase, consider the free body diagram of the wedge. Remove the wooden logs. In place of the wood, you apply the reaction forces acting on the wedge by the wood on either sides. So if this is the wooden log, you just extend this part as a triangle and the included angle as 2 alpha. If P is the vertical load acting downwards, then R1 and R2 are the total reaction force acting on the each edges of the wedge. For example, R1 now is the reaction of N1 and mu N1. N1 is, suppose this one, normal reaction of the wood on right side onto the wedge, and mu N1 will be in upward direction because P is moving, allowing the wedge to move in downward direction. So the resultant of N1 and the mu N1 is R1. I am considering this R1 acting on this edge at an angle of phi, which is a friction angle to the normal reaction N1. This in turn is at an angle of alpha to the horizontal. This is simple trigonometry and geometry. Then comes your R2, the similar thing, which is the total reaction force of N2 and mu N2, which is acting in upward direction. This R2 is acting at an angle of phi with N2, an angle of alpha with the horizontal. Now, knowing these forces, that means R2, R1 and P, resolve these forces to the x-axis and y-axis and then apply the equilibrium equations. For instance, when I resolve these two forces, R1 becomes R1 cos alpha plus phi, the horizontal, and R1 sin alpha plus phi, vertical. This R2 now becomes R2 cos alpha plus phi on horizontal and R2 sin phi plus alpha in the vertical direction. So, in sigma fx equal to 0, you have two forces, one is R1 cos alpha plus phi and R2 sin cos alpha plus phi, which are acting in opposite direction to each other. So, here R1 is equal to R2. Now, apply sigma ffy equal to 0, in which the sum of the vertical forces are equal to 0. In this case, it is R1 sin alpha plus phi, and in this case R2 sin alpha plus phi, both are in the same direction, upward direction, minus P, downward direction, equal to 0. So, using these two equations, you are able to find the applied force P is equal to 2R1 sin alpha plus phi. So, P is the function of friction angle, wedge angle and the reaction force. Now, getting into the second part of the problem. Here, consider the free body diagram of the wedge without applying P. Now, this becomes when the wedge has been driven inside the wooden log and the force P is removed. The wedge now tries to split out. So, the direction is reversed. Also, that means no force P acting on the wedge. Now, in this case, your R2 is making an angle of alpha with the horizontal and R1 is making an angle of alpha with the horizontal. So, sigma resolve these two forces again to x-axis and y-axis as R2 into cos alpha minus pi in here and R1 into cos alpha minus pi in this direction. Since both are in opposite direction, the sum is equal to 0 here. So, here again R1 is equal to R2. Now, resolving the forces in y direction, you have R1 sin alpha minus phi in vertically upward direction, R2 sin alpha minus pi in vertical direction. Both these two forces are in upward direction. Then their sum is equal to 0 here. Then you have 2, since R1 is equal to R2, 2R1 into sin alpha minus pi equal to 0. So, alpha is equal to pi. That means when the wedge angle is equal to the frictional angle, that's the maximum angle of the wedge, so that it will remain embedded in the log.
Now, let us understand the mechanism of power screws. A power screw is a machine element which is used to convert a rotary motion into uniform longitudinal motion. It is basically used in screw jacks, valves, presses, tensile testing machines and machine tools. So, let us now understand in detail exactly the working principle of these power screws. The power screw actually assembly comprises of a screw, that means a threaded rod on which the threads are cut externally. Basically, the threads are of square shape or acme profiles. So, these are the externally threaded rod. Then the next important element in a power screws are nut. The nut will have internal threading, either square thread or acme threads. So, the reason to choose these type of threads is because the power screws are such elements which has the capacity to handle higher loads. Sometimes the loads are in tons. So, that is the reason you opt for square thread or acme threads. Then this is the collar on which this entire thing is supported. Okay. Now, if F is the load in tons, external load that is acting on the screw may move up or down based on the rotary motion that you give to the nut. So, what exactly is happening in between the screw and the nut? Suppose, as I said, the screw is a cylindrical rod on which the threads are machined, either square thread or acme thread. Then a nut is another machine element in which these same similar type of threads are internally machined. So, it has an internal threading, this has an external threading. Now, this is inserted inside this screw, and when the nut is rotated, it slides on the screw, either upward direction or downward direction. If you rotate the nut in a clockwise, it may move in upward direction. Now, let us understand what exactly happens in the interface between the nut and the screw. When the nut is rotated in clockwise direction, the nut moves in upward direction. When the nut is rotated in the anti-clockwise direction, then it moves in downward direction. Since the nut has internal threads, those internal threads are now in contact with the external threads of the screw and take the path. The path taken by the nut while moving up or down is a helical path. Now, let us understand the mechanism of a screw. The screw is, imagine as a cylindrical rod on which the threads are cut like this. This is the thread that goes this way and again this way and again this way, right, and it makes an helical angle alpha. Now, since is the cylinder, the diameter is dm and this is the length L. Now, when you cut this cylinder for a development and open the cylinder, it becomes a rectangle. The length remains the same for the rectangle, but the width is now nothing but the circumference of the circle because it is a cylinder. Now, when you draw that, this is a development of the single thread screw whose width becomes pi dm, that is the circumference of a circle, and the length remains same. In this, if you just trace the path of the thread, helical thread, then it looks like an inclined line. Now, if this is the nut holding the load, external load 4F, which can be in tons, and this is a screw which has a helix angle alpha, and L is the distance between the first thread and the second thread. That means this portion to this portion. I am calling it as L. L is nothing but lead. Lead is the distance travelled by the screw for one revolution. The distance, once you rotate this screw, the distance travelled by the path from this point to this point is what is called lead. Sometimes the lead is 1 into P, it is called single thread. This is how you represent a single thread. Sometimes it can be 2 times P, that is double thread. Double thread means it has threads here and here. And sometimes it can be 3 times P, it is triple thread. So these are called, I represent as N into P, multi-threaded screws. Multi-threaded screws. Based upon the load that we need to carry, the multi-threadeds are used in the applications. Right? Now, let us clearly understand one screw jack mechanism and then try to go into the mechanics part of this. So, as I said, the power screw or application as a screw jack will comprise of a screw thread. This is a screw rod and this is the threading part. This is the threading part, internal line that I have given, which is having a diameter of dm. This is the nut. Assume that it is fixed. Then you have a cup-like arrangement so that you can place the load that can be in tons, can be placed here. Now, the objective is to raise this load up or down. This happens by rotating the screw. To rotate the screw, you have this arrangement of a handle and then you apply Q, an external force, so that it creates a torque Q into A, where A is the length of the handle arm. Now, that torque, which is an external force or action done on the screw, will create a reaction by creating a force P at a distance of Rm, that is the mean radius. So, P is nothing but a reaction exerted on the screw at a radius Rm. Right? Now, basically there are two phenomena that are happening in this screw jack. One is the load is rising up. The next one is the load is sliding down. Now, let us take the first case, that is case 1. As I already mentioned that this forms a wedge problem. This motion of the nut on the screw in a helical path is similar to a wedge problem. Is similar to a wedge problem. So, we will directly consider a wedge here. This is one first thread, this is a second thread, and the distance between the thread can be the lead. Then place the load on this, okay, and alpha is a helix angle and this is nothing but pi dm, that is the circumference of the thread wound on the cylinder. Then what are the forces that are acting on the body? In the first case, let us take the body moving upwards. Body moving upwards. That means the motion is in upwards. In this case, as you know, the force is always acting perpendicular to the ground surface. Then there is a frictional force and normal reaction. So, normal reaction acting perpendicular to the inclined surface. Since the body is moving up, I take mu n in downward direction. In addition to this, you need to represent P, the force acting on the thread because of the torque that is acting on the screw. So, that force is acting this way. So, now you have actually here two axes. I can say y dash and x dash x dash. Now, if you just again put them in the axis in this way, x dash and y dash. This is the force F at an angle alpha. And this is a P, you can put this P here at an angle alpha here, and mu n is on the same axis, and also n acting on the same axis. So, these are the four forces that are acting on the load. Now, you resolve these forces. This happens F cos alpha and F sin alpha, and this resolution is P cos alpha, P sin alpha. That is it. Now, your sigma Fx equal to 0, equilibrium conditions. So, the sum of the forces acting in x direction are 0. I take mu n minus F sin alpha minus P cos alpha equal to 0. Then sigma Fy equal to 0. Then in this case, F cos alpha minus n minus P sin alpha equal to 0. Now, consider mu n as tan phi, where phi is called the friction angle. So, solving these two equations, you get a relation P equal to F tan phi plus alpha. So, this is the expression is important to know the torque required by the effort that you need to apply on the screw to raise the load in upward direction. So, P is the external force, or that is the effort that we give. F is the main load that it needs to carry, to lift or to slide down into tan of phi friction angle, alpha thread angle. So, this is case 1. Now, let us understand case 2. In case 2, the similar thing, but the direction of the friction is in upward direction because the body is moving downward direction. Okay? And so, the frictional force is in upward direction and the force P is again in the similar direction with N. And you do the same exercise on this, resolve all the forces to one axis and then solve the equilibrium equations to obtain P is equal to F tan phi minus alpha. So, this much amount of force is required to lower the load on the through the screw, to lower the load through the screw. So, these two has to be noted. The next aspect in power screws is the overhauling and self locking of screws. See, let us understand first what is overhauling. Now, if you know the torque required to lower the load, that is, as we have just recall, this is a screw, this is the nut, screw and thread, and once you rotate the screw, the load may rise or lower. So, the torque required as I said can be in terms of force, that is the weight of the load, is expressed as F into dm by 2. The dm by 2 is half the radius into tan phi minus alpha. If considering these two angles, where phi is the friction angle and alpha is the helix angle of the thread or screw angle, if phi is greater than alpha, obviously the torque is negative. This is also known as back driving screws. Now, what happens in this is, this load will start moving down without the application of any torque. It just continuously keep moving down, sliding. Now, here effort should be given to the screw to resist the tendency of the load to descend. So, that is what is called as overhauling or otherwise back driving screw. This happens when the frictional angle is less than the helix angle. The next phenomenon is self-locking, that is vice versa to this. If phi is greater than alpha, the friction angle is equal to or greater than the helix angle, here the torque becomes positive because this is more than this. The torque is positive. In this, the screw remains stationary and effort is required or applied to lower the load. So, these are the two important mechanisms of a power screw which are used mostly in many applications.
So, let us understand an application of a power screw. A very simple application. This is a C clamp. This is this power screw. This part is the nut part which has internal threaded, and this part is a movable part. It translates as you rotate this handle. Then this is a fixed part of the clamp. You place any component in between the movable and fixed frame, and once you rotate the screw, it translates into linear motion and holds the clamp tightly. So, let us see the problem. A clamp of double threaded screw. So, this screw here is not a single thread, it is a double threaded screw. Has a diameter of 10 mm. The screw diameter is 10 mm. The friction is 0.3. The friction between the nut and the screw is 0.3. If torque is 40 Newton meter is applied in tightening the clamp. So, this part when you rotate, that is about 40 Newton meter. Then as I said, the movable frame will tighten the wood. The force is exerted on the wood. So, question is, determine the force exerted on the wood. A. And B is the torque required to loosen the clamp. So, there are two questions in this particular problem. So, let's solve the problem. Considering first the force exerted on the wood. That means when you rotate this handle, the movable frame will exert the force on the wood and tighten it. So, what is that force that is applied on it? So, we will see what is whatever given data to us. One is lead. Lead is 2 times P because it is a double threaded part. So, the P is nothing but pitch. So, you can assume the value of pitch if it is not given. Pitch can be 2 mm. So, 2 times of P, 4 mm. Then comes your tan theta, which is nothing but L by pi d. L is the lead by circumference pi d. So, you are getting angle theta as, this is a wedge angle. Theta here is wedge angle, 7.3 degrees. Okay, let's go back to the working mechanism of this. As we know that the nut and the power screw of this part is considered as a wedge with a block. So, you can consider that as a wedge with a block having a weight of W. The block of weight of W. Here we are saying that W is the force that is exerted on the wood. Now, on this, in the first case, the force is exerted on the wood is treated as motion impending up the plane. So, you are creating a motion moving the block in upward direction. So, when the block is moving upward direction, the frictional force will be acting in downward direction. So, here we consider resultant reaction of N and mu N, that is R, which is acting at an angle of theta plus phi, where theta is the wedge angle. So, you need to determine Q. As we know that one edge of this wedge is lead and the base is nothing but the pi d, that is circumference of the rod, screw rod. Now, coming back to the calculations, we know that the wedge angle is 7.3 degrees. So, mu s frictional coefficient is 0.3. So, the angle tan phi is equal to mu s is calculated as 16.7 degree. Then you have Q into R is equal to torque, 40 Newton meter. Now, Q is nothing but the resistance force offered on the thread due to the applied torque, that multiplied by the radius of the screw rod equal to 40. So, then you get Q is equal to 8 kilonewton, since R is equal to 5 mm. D is 10 mm, is R is 5 mm. You got Q as 8 kilonewton. Now, coming to this vector diagram, this vector diagram, triangle vector diagram, is drawn based on W, Q, because you are moving it upwards, and R, right? So, Q as 8 kilonewton is the only known value. What you need to determine is W. What is the force that is exerted on the wood? Now, since we consider this as the wedge problem on which the motion is impending in upward direction, we use the expression W is equal to Q divided by tan theta plus phi s, where theta is the wedge angle, phi s is the frictional angle, and you substitute this value. The value is 17.97 kilonewtons. Coming to the question B, it is the torque required to loosen the clamp. That means rotate the handle in anti-clockwise direction so that the mobile frame moves towards right and loosen the wood. For that, you can directly use this wedge and block problem with motion impending down the plane. So here I am applying the force Q downward direction, and the W and R accordingly to the motion of the block. So using the expression of motion impending in downward direction, Q is equal to W tan phi s minus theta. So we already know that W is 17.97 and apply all these values, you are getting Q as 2.975 kilonewton. So torque is Q into R, that is 14.87 Newton meter. That means what you understand here is 40 Newton meter is applied to tighten the clamp and 14.87 Newton meter is applied to loosen the clamp. Okay. Here phi s is greater than theta. Since this is happening, the screw is self-locking.
Now let us understand the concept of connected bodies. The connected bodies majorly has three major components. One is suppose block A, which is of 400 kg, block B of 200 kg. So two heavy objects are connected with another heavy object which is of 100 kg weight. Call it as strut. So strut is basically a multi-force member which is pin jointed on block A and on block B. So the pins here will develop reaction forces. It happens when a force, applied force P is acting on the body A, the body A moves towards right direction and the body B moves in upward direction. Then the pin here will have reactions of AX, AY, and here it is BX and BY. So these are the reaction forces that are occurring on the pins. So let us solve this problem for the value of P. So first let us draw the free body diagram of strut. As I said, the strut is a multi-force body where the weight of it is acting here downwards. Let me say WAB, which is 100 kg, and the BX in this direction, BY vertically opposite, AX opposite to BX, then comes your AY. So when you apply the equilibrium equations, sigma fx here equal to 0, your AX reaction force in x direction is equal to Bx, that is the reaction force at B in x direction. Now for sigma Fy equal to 0, now let us consider the vertical forces here, that is the weight of the strut lies exactly at the midpoint of the length of the strut. So the length of the strut is immaterial for us. So we can consider sigma Fi equal to 0 for Ay equal to By, which is equal to Wab by 2, which is 100 by 2, that is 50 kgs. So, this weight is now distributed at the pins as W by 2 and W by 2. Now, knowing these values, let us go for the free body diagrams of first inclined surface. Now, once you draw the free body diagram for an inclined surface where the object is moving in upward direction, the motion is in upward direction. The weights that are acting on this are, one is the self weight 200 plus the weight of the strut, which is 50. So, totally 250 vertical weight is acting on the body. Next one is the reaction Bx. The reaction Bx in this direction. Now, this slope is 45 degrees with the horizontal line. Okay. Now, let us draw the normal reaction. Let me say NB. Now, since the body is moving up, your frictional force will be in downward direction, mu NB. Right? Now, let us resolve the forces onto this plane or on this plane. Okay? So, let me resolve that everything into this vertical plane. So, this is 45 degrees. I call this as NB sin 45, NB cos 45. Now, this itself is again mu NB, this is 45, cos 45, mu NB sin 45. Now, this angle with this is again 45. So, this becomes Bx cos 45 and this is Bx sin 45. So, these are the forces that are acting on the object which is having 200 kg weight. So, again write down the equilibrium equation, sigma Fx equal to 0. So, my axis is here, this and this is the axis. Okay. So, sigma Fx equal to 0, let me start from here, that is minus mu NB cos 45, this one plus Bx sin 45 minus NB sin 45. Okay. Let me round off whatever that we have completed. This is over, and this is over, is equal to 0. Now, let us go for the next equilibrium condition, sigma Fy equal to 0. These two put together, that is minus 250 plus Bx cos 45 plus NB cos 45 minus mu NB sin 45 equal to 0. This is equation number 2. So, from here you have two unknowns, one is NB, another one is Bx to solve. So, let us go for the next free body diagram, that is the block A. the block A here is on a horizontal plane where the P is acting in this direction. So, the friction here acts in mu NA in opposite to its motion, and this is NA. We know that motion is in this direction. Okay. Then you have the weight of the object, that is 400 plus 50, right. Then you have B or AY, which is equal to BX, AX equal to BX. You can either use AX or BX. Now, the angle subtended with this is 30 degrees. So, we call this as 30 degrees. This is a very simple system of forces. So, you just resolve this into horizontal Bx cos 30 and Bx sin 30, right. Then apply the forces here as sigma Fx equal to 0, this one plus P minus Bx cos 30 minus mu Na equal to 0. This is equation number 3. Then sigma Fy equal to 0, 450, that is minus Bx sin 30 plus Na equal to 0. So, equation 4. So, after solving all the simultaneous equations, you calculate the unknown P, which is the applied force on block A. The P now comes around 397 kg. So, the force of 397 kg is applied on block A, which is of 400 kg, to push 200 kg upwards on an inclined surface. So, that is how you solve a connected problem.
Now, let us look at problem number 13. A uniform bar AB 10 meters long and weighs 300 Newton is hinged at B and rests upon a 500 Newton block at A, as shown in the figure. If the coefficient of friction at all contact surfaces is 0.4, that means here as well as here it is 0.4, then find the horizontal force P required to start moving the block of 500 Newton. The impending motion of the block is towards right and the frictional force resists the motion, hence it acts towards left on the block. So, the solution for this is also available in the notes provided in the description link. Let's go to the next application, ladder. Many a times we come across the uses of ladder for attaining the higher heights. We observe that care is taken to place the ladder at an appropriate angle with respect to the ground and the wall. We try to adjust the friction offered by the ground and the wall in contact with the ladder. The forces acting on ladder are normal reactions, frictional forces between the ground and the wall and the ladder. Weight of the ladder, weight of the man climbing the ladder also is considered. Considering the free body diagram of ladder, we get general force system. Simplification of the system by considering equilibrium condition can be worked out by following equations. That is sigma fx equal to 0, sigma fy equal to 0 and sigma m is equal to 0.
Okay, now let's solve problem number 14, a ladder problem. Now imagine a ladder is resting on two surfaces. One is wall, vertical surface at point B, and the ground surface at point B. Now this ladder is having a weight of 100 newtons and the length of 5 meters. Imagine a man is climbing the ladder. This is the man climbing the ladder which is inclined at an angle of 60 degrees to the ground surface. Now the question is, how much distance up along the ladder a man weighing 600 Newton can ascend without causing it to slip? So the ladder should not slip while the man is climbing up, is what is to be understood. Now, what we need to say is, let us assume that distance he climbed it to D till such time the ladder isn't slipping. Now, the weight of the ladder, 100 Newton, is placed exactly at the center of the span length, that is around 2.5 meters. Now let us draw the free body diagram for the ladder. Now this ladder is having a weight of 100 newtons at a span which is having a span length of 5 meters, and this is around 2.5 meters. And we also know that there is a person of weighing 600 newtons at a distance of D from the ground B point, or let me put the B point here above and A point here. Now, when the ladder is slipping, that means the ladder slides in this direction on the ground and downward direction on the vertical surface. Now, based on this motion direction, we can represent the frictional resistance. So, here at the ground, since it is moving in rightward direction, the frictional force will be in left direction, mu NB, and the normal reaction would be NB. Now here, because it moves downwards, the frictional force would be mu NA and normal reaction as NA. Right? Now with this motion, let us now calculate. Our interest is to find out the distance D. Applying the equilibrium of motion, sigma fx is equal to 0, I have NA is equal to mu NB is one equation. Sigma Fy equal to 0, vertical forces 100 plus 600 is equal to NB plus mu NA. The mu here as well as here are same. Then you need to understand the angles moment at B, that is sigma MB equal to 0. Now taking this triangle formed by the ladder and the vertical face is 60 and this is 5 meters. So 5 cos 60 degrees and 5 sin 60 degrees are the distances of adjacent and opposite sides, right? Now take moment about B. What are the forces that are contributing to the movement? NA will contribute, mu NA will contribute, 100 will contribute, 600 will contribute, whereas these two does not contribute because they are lying on the moment center. Now let us take NA. NA is in this direction, the moment center at this point rotates in this clockwise. So I write it as plus NA multiplied the perpendicular distance is 5 sin 60. Mu NA, which is vertical in upward direction, rotating towards the moment center, that is this one, is again clockwise, saying mu NA multiplied by the perpendicular distance of this, that is 5 cos 60. Then comes another triangle for you. Another triangle here is around 2.5, same 60 degrees. So this forms 2.5 cos sin 60 and 2.5 cos 60, right? So 100, the weight of the ladder rotating about this moment center in anti-clockwise direction. So minus 100 into the perpendicular distance 2.5 cos 60. Then 600 rotated about moment center again in anti-clockwise direction minus 600 multiplied by this distance, which happens to be d cos 60 into d cos 60 is equal to 0. So you have 3 equations. So after you solve these 3 simultaneous equations, you get the distance the human being climbed on the ladder to be d is 2.034 meters. So after he climbs not even more half of the ladder, that means at a distance of 2.034 meters, the ladder starts slipping, impending motion. Okay. So this is how you need to solve the ladder problems.
Let's move to the next application, belt friction. The belt or rope is wrapped around the pulley to transmit power or effectively used for braking systems. To evaluate the effectiveness of the system, the tensions in the belt or rope are of importance. So consider this as a driver pulley and this as a driven pulley or otherwise called follower pulley. And the belt slips around the pulley from tight side to slack side, causing 2 different tensions, T1 and T2. So this is the schematic diagram of a pulley and the belt wrapped over the pulley, having 2 different tensions, T1 and T2. Let the belt wrapped over the pulley be theta, and d theta is the small elemental segment of belt in contact with the pulley, and m is the rotational movement caused on the pulley.
Now let us understand the mechanics of belt friction. Belt is a mechanical element used for power transmission. Now consider two pulleys of different diameters, one being the driver pulley, the other being the driven pulley. The motor source, that is like an electric motor, is connected at this point, and the power is transmitted to the driver pulley through the motor. Now, when the driver pulley is made to rotate, the belt that is wrapped around the two pulleys rolls such a way that the driven pulley is rotated. So, here the friction that is acting at the contact surface of the belt and the pulleys becomes the driving force for power transmission. Now, since the belt is wrapped around the two pulleys, the belt will be noticing two types of tensions because of one being tight side, the other one being slack side. And there is another important point to be noticed is the wrap angle of the belt on the pulleys. Let me call it as beta. Now, coming into the details of this frictional force movement on the belt. Let me take a small part of the belt. This is the belt, and one side as tight side, I call it as T2, and slack side as T1. The difference of these tensions will transmit the power. The frictional force which is at the contact surface of the pulley and the belt will be acting in the opposite direction. Right? Now, let me take a small elemental strip of this belt in this way. This forms the elemental strip with an included angle of d theta. Right? Now, since the frictional force is moving in this direction, I represent it as dF. Now, dN is the normal reaction force caused by the pulley onto the belt. Then the tensions are represented at the cut section of the belt, one T, that is slack side, T plus delta T on the tight side. If this is d theta, the angle subtended by the surface with this tension force is d theta by 2, and again with T plus delta T with the surface of the belt as d theta by 2. Now, with these forces on an elemental strip, let us write the equilibrium equations. For that, I will put all of them on x axis and y axis. This is y, this is x. Okay, I will treat this as x axis and this one as y axis. So, on y axis, I have dN, x axis I have dF, these two. Then I resolve this to T cos d theta, T cos d theta by 2 in horizontal direction and T sin d theta by 2 in vertically downward direction. Here it comes as T plus delta T into cos d theta by 2 in the horizontal direction, and then T plus delta T into sin d theta by 2 in downward vertical direction. Now, apply the equilibrium equations onto the belt. Sigma Fx equal to 0 gives you some of the forces in this direction positive and in this direction as negative. I call t plus delta t into cos d theta by 2 minus df minus t cos d theta by 2 equal to 0. Let me call it as equation 1. Now, sigma Fy equal to 0 gives you dn, forces in this direction positive, in this direction negative. So, plus dn minus t sin d theta by 2 minus t plus delta t into sin d theta by 2 equal to 0. Let me put it as equation 2. Now, assume that cos d theta by 2, a small angle, is equal to 1 and sin d theta by 2 equal to d theta by 2. Substitute these values in the above two equations and solve the equation to get the final dt equal to t into mu into d theta. So, I pull this here, call it as t by t equal to mu d theta. You integrate these two this expression on both sides with this as T1 T2, that is the varying tensions, and this as 0 to beta. Beta is the wrap angle. Okay. Then when you solve this, this comes as logarithmic E T2 by T1 equal to mu beta, or I can call this as T2 by T1 is equal to E into mu beta.
Let's understand the velocity ratio of belt pulley systems. Velocity ratio is defined as the ratio of velocity of the driven to the velocity of the driver. If n1 is the speed of the driver in RPM, d1 is the diameter of the driver, and if n2 is the speed of the driven in RPM, d2 is the diameter of the driven. Here, the length of the belt passing over the two pulleys per minute will be the same. So, you need to note that the linear velocity is constant. So, you call V is equal to R omega. So, omega is pi d n. Here, when this linear velocity is constant or same, you equate pi d1 n1 equal to pi d2 n2. So, that means n1 by n2 is equal to d2 by d1. That means the speeds are inversely proportional to the diameter of the pulleys. The smaller diameter of the pulley will rotate with a high speed, and the bigger diameter of the pulley will rotate with a low speed. So, this is the ratio for the belt pulley system.
Now, let us understand problem number 15. Here, there are two blocks. One is of 2000 Newton and another block, unknown weight W, is resting on 2000 block, and these two in turn are resting on a inclined surface at an angle of theta. The slope of this is given as tan theta is equal to 3 by 4. Now, these two blocks in turn are held with a rope passing through a pulley in this way. Now, the question is, determine W to prevent the down plane motion of 2000 Newton, to prevent this motion of this coming in this direction. How much of W has to be placed on the top of this block? A very simple way of solving this problem. you divide this problem into 3 free body diagrams. The first free body diagram, you consider both the blocks and represent the forces acting on it. Write down the equilibrium equations. And in the second free body diagram, consider only the top block. Represent the forces on it and solve the problem. And the third free body diagram is consider only the belt pulley element and apply the equilibrium conditions and solve the problem. Now coming to the first free body diagram, I have taken both the weights, the block 1 W, block 2 2000 on an inclined plane. So since these 2 blocks are attached to the ropes which have tensions T2 and T1. So I consider the tension pulling T2 and T1. Then W plus 2000 is acting in a vertical direction and N1 is a normal reaction by the inclined phase onto the bodies. Now our interest is that this should not move down, right. So there should be a frictional resistance acting in upward direction. Then in this case, you just have to resolve these forces onto this plane y, y, x, x and solve the problem of this simple W plus 2000 cos theta and in this W plus 2000 sin theta. So sigma fx in this case becomes positive sides this one T1 plus T2 plus minus W plus 2000 sin theta plus mu n1 equal to 0. Sigma fy equal to 0 is W plus 2000 cos theta equal to n1. So you have 2 equations. Now coming to the second free body diagram where you are considering only the top block. Now in this, the forces that are acting on this block are the weight of the block obviously, the tension of the rope, normal reaction exerted by the 2000 Newton onto the W block is upward direction and the frictional force acting here, I call it as F2 which is in downward direction mu N2. Now here the equilibrium condition sigma fx equal to 0 goes as this as W cos theta and this as W sin theta. So it is plus T2 minus W sin theta minus mu N2 equal to 0, equation number 3. Then W cos theta is equal to N2 is equation number 4. Then coming to the free body diagram 3, you have pulley and belts acting this way and the equation goes as T to tight side by slack side equal to e to the power of mu beta, where beta is the wrap angle since it is touching in 180 degrees. So take them in radians, pi radians. So you have T2 is equal to T1 into e to the power of mu beta. Mu is a given value which it goes around 0.3 and beta is pi radians. So you get a relation between T2 and T1. Those relations you substitute here and theta is already known as 3, tan theta is 3 by 4, you substitute, you are going to get W which is around 273 newtons. So you apply a weight of 273 newtons on the top of 2000 newton, so that you can prevent the down plane motion of 2000 newton body. Okay, let us discuss problem number 17, an interesting practical problem. Now, we have this a braking mechanism in which there are three major components in the system. One is compound pendulum, second one is the hydraulic cylinder, and the third one is the brake lever. Now, in the compound pendulum, you have two pulleys, a small pulley of radius 400 mm and a bigger pulley of radius 600 mm, which have concentric, means have the same center of rotation. So, this is a compound pulley and a weight of 2000 newtons is hanging on a small pulley. So, the small pulley rotates about B in counterclockwise direction. Now, a brake lever is attached here, where the brake pad comes in contact with the compound pulley, and the lever on the other side is hinged at point A. This is the hydraulic system where the cylinder and the piston hydraulically operated. The piston moves down on the lever to arrest this motion of the pulley. So, the question is, how much force is required for this system to arrest the motion of the pulley through the pad, brake pad. So, when a force is applied in this direction, then the brake pad will apply force on the pulley, resisting the motion of the pulley. So, let us solve this problem in parts. In the first part, we will take this set of pulley and the pad. Now, when you are taking the free body diagram of pulley, okay, you have the pulleys here, set of pulleys here with B, and this is the force 2000 newtons in downward direction, and the brake pad exerts force on the pulley, causing the normal reaction on the pulley N. While it is exerting force, the frictional force is caused at the contact surface. That frictional force direction depends on the direction of the rotation. Now, since it is rotating in this counterclockwise direction, the frictional force acts in opposite to its motion. So, you have three forces acting on this pulley. So, simply you take sigma MB equal to 0, and in this sigma MB equal to 0, take the moment about B. The force 2000 will contribute to the moment, and force F will contribute to the moment, and N does not contribute to the moment as it is lying on the same axis of the moment center. So, the force 2000 multiplied by this distance, which is 400 mm, and this distance is 600 mm. So, this force 2000, moment about B rotates this direction, which is counterclockwise. So, minus 2000 into 400, and this force towards moving towards B, which is this direction, plus F into 600 equal to 0. Then you have the value of F calculated. Then but F is equal to mu into N. mu is given as 0.4 in the problem. That is the coefficient of friction between the contact of the brake pad and the pulley. So when you substitute, you get the value of n. Agreed. Then coming to the next free body diagram of a brake lever. Brake lever. Agreed. So the brake lever, if you draw, you have the normal reactions and frictional force equal in magnitude but opposite in direction. That means the normal reaction on the pulley is in upward direction, then the normal reaction on the brake pad would be in downward direction. And the frictional force in left now will be in right in this brake pad, equal and opposite. Then the force applied here at a distance of 500 mm from the hinge is in upward direction. So you know that this is 500 mm, this is 1000 mm, and this distance is 100. Simple thing is, apply moment about A. So here all the three forces will cross moment about A. That is sigma ma equal to 0. F in this direction, moment about A is in this direction, rotating in clockwise, that is plus F into 100. N about movement in this direction, that is minus N into 1500, 100 plus 500. Then P in this direction, that is plus P into 500 equal to 0. Now since you get the values of N and F from here, substitute those values here and get the value of P. Here the P is around 4860 newtons. So 486 kg force is required to be applied on the lever at a distance of 500 mm from the hinge so as to arrest the motion of compound pulley through the brake pad.
Let's understand the concept of rolling wheel. Here consider a body rolling without slipping on a surface and let P be the externally applied force. In a rolling wheel, there are two phenomena that happen. One is the wheel rotates about its own center of rotation, and the second one is the wheel moves forward. Okay, so let us consider this as a rolling wheel with O as a center of rotation, and this wheel is affected by the linear acceleration of center of the wheel O and the angular acceleration alpha about O. The point P is the instantaneous center of this wheel, which is actually the contact point of the wheel and the surface. So this wheel, which is rotating with an angular speed omega and acceleration alpha, is now affected by linear acceleration A is equal to R alpha and angular acceleration about O. Now the second phenomenon is moving forward. That is when P, a horizontal force which is acting tangential to the wheel, causes the wheel to move forward. Now since the wheel is touching the ground, the major frictional force is acting to resist slipping on the surface. Since frictional force is unknown, the moment about C is considered first. For this, you have to first draw the free body diagram. This is the free body diagram of a rolling wheel. So the wheel has weight, self weight W acting in downward direction. So the normal reaction N caused by the ground onto the wheel is acting in upward direction, perpendicular to the ground surface. Then there is a force P acting on the wheel in the direction towards right. Then the frictional force FF acts in the direction towards left at the contact surface. Then your mr omega square, or otherwise W by G into A, is acting towards the left, and I alpha, that is the torque, acting at O. Now, in order to determine frictional force, you apply equilibrium equations on this rolling wheel. The first thing is, consider the moment about C, mc equal to 0. That means, take the moment of all the forces about this point C. So what are the forces that contribute to the movement? Is P contributes to the movement about C. W does not have any movement about C, as it is acting on the same line of action. So the distance is 0. Then you have W by G into A, which is at a perpendicular distance of R from the C moment center, also contributes to the moment. Then anyhow you have I naught alpha, where I naught is mass moment of inertia, alpha is the angular acceleration acting about O. So when you take the moment here about C, frictional force and normal reaction also does not contribute to the movement about C. So let's start taking the moments, that is P multiplied by 2R, because it is the diameter, about C. That moment is in clockwise. Just assume the vector head rotating about the moment center in this direction. So it's in clockwise. So sum of the clockwise movements is equal to counterclockwise movements. So if I write 2 into P into R is the movement caused by applied force P, then W does not have any role, leave it. Here W by G into A at a distance of R. Now if the arrowhead is towards left, rotate the arrowhead towards the movement center, it moves in this direction. That means in counterclockwise direction. So you can either put minus or you can take it to the other side of the equation. So W by G into A into R, a counterclockwise movement. Now coming to this I naught alpha, that is mass moment of inertia into alpha in a counterclockwise direction. So that adds up to this. So put together you have an expression for P which is equal to WR alpha by 2G plus I naught alpha by 2R. So this is this expression caused because of the movement about C. Then comes the forces in vertical direction, sigma Fy equal to 0. You have two forces, one is W and the other one is N. So you equate N equal to W. Then you have the forces in horizontal direction. That is P equal to W by G into A plus FF. So from here you can get your frictional force FF is equal to P minus W by G into A. That means the frictional force is a function of the applied force, the weight of the wheel, gravity, and the acceleration acting on the body. So if the body rolls on the surface without slipping, then only the relation A is equal to R alpha holds good.